Okay, I'm going to find the volume of this function when it's rotated around the y-axis using the Pappus theorem. Basically what the Pappus theorem states in simpler terms than the way the book states it is it's 2 pi times the centroid of your shape, whatever figure it is, times the area of your figure. And that's basically the mass of the figure times the vertical distance, which will represent the place that the force is applying a certain moment. So like this centroid is the certain moment that's applied, and that's how you find the centroid. So anyways, to find the area of this function, and the function is negative x plus 1, it hits the x-axis at 1. So we want to integrate it from 0 to 1. We integrate through integral of x is x squared over 2. This becomes negative x from 0 to 1. So we apply this from 0 to 1. This right-hand side, when you put in 0, becomes 0. Evaluate at 1, you get 1/2, negative 1/2 plus 1. So our area is 1/2 of a unit. And you can think that in terms of mass. Now to find the centroid, we need to do, basically it's the moment of this thing. So it's the force, which is the mass, times its distance. And if we think of each slice, we have a height, which is represented by the function. We have a change in height, which is represented by dx. And we have an x value, which is kind of just the distance over for each individual slice. So we integrate that also from 0 to 1. Same steps as before, just that we have another x value now. But when we integrate through, we get a value of 1/6. And that's the moment. Now to find the centroid, it is the moment divided by the mass. So we take our moment of 1/6 and divide it by our mass of 1/2, and we get the centroid value is 1/3. And that makes sense too, because the centroid of all right triangles is 1/3 distance from the right angle of the triangle in both directions. So since this is 1, the centroid is a 1/3 unit to the right of the base. So now to find the area, it's just, or the volume, excuse me, when we rotate around the y-axis, it's just 2 pi times the centroid times the area. And we use the centroid in terms of x because that's the distance from the axis, and that's what Pappus theorem states, is that you need a big radius, which is from the axis you're rotating. And our centroid represents that distance. And then it's multiplied by the area of the function. So we get 2 pi times 1/3, which is the centroid, times 1/2, which is the area, and we get a value of pi thirds for the volume when this function is rotated around the y-axis.